Okay. So, we will take a small example of that. Suppose this is the example is taken, it is example 2, right. So, in the line 5 minus j 2 ohm one impedance is connected, this is star connected, load 10 plus j 8, 10 plus j 8, 10 plus j 8 ohm, and this is your star connected source 110 angle 0, 110 angle minus 120, 110 angle minus 240, and in the line each line 5 minus j 2 ohm, 5 minus j 2 ohm and 5 minus j 2 ohm impedance is connected, and current IA, IB, IC all is given, right. So, now Z star that means what you can do is that you should not be confused with this. What you can do is this all are same, this 5 minus j 2 and 10 plus j 8 you add together, make it as a Z star, right, that is the idea. So, in this case your Z I is equal to 5 minus j 2 plus 10 plus j 8 is 15 plus j 6 ohm. Therefore, IA is equal to compute same relationship, although it is line it is given, we have clubbed together, right. Therefore, IA is equal to Vn upon Zy is equal to 110 angle 0 by 15 plus j 6 is equal to 6.81 angle minus 21.8 degree ampere. Similarly, we have derived this relation IB is equal to IA angle minus 120 degree. So, it will be 6.81. So, and IA or what you call IA is 6.81 minus 21.8 degree. So, it will be minus 21.8 degree minus 120 degree. So, minus 141.8 degree, right. Similarly, IC is equal to IA angle minus 240 degree. So, 6.81 angle minus 21. This we have got even 21.8 degree minus 240 degree. So, this one will be IC is equal to 6.81. Actually, there should not be any doubt or anything. Actually, this one IA is equal to this one, that means 6.81 angle minus 21.8 degree into your this angle minus 120 degree, right, because into 1 this one. So, these two are added. So, that is why your this thing is there, right. Similarly, here, right. So, IC is equal to you will get 6.81 your 98.2 degree. Why? This is minus 240 minus 21.8 degrees there. Just the other way you add 360 degree with this. Just the way you show no VB VA that VC lagging minus 240 degree. So, we add 360 no other way you saw lagging rather than lagging we can show other way it is leading. So, you add 360 degree with this. So, 360 minus 240 minus 21.8 you will get 98.2 degree ampere. You do it yourself, right, draw the phasor diagram. So, line voltage is equal to VL, and we know VL is equal to root 3 into phase voltage, right, magnitude. Therefore, we know VAB is equal to, therefore, this also we have derived, VAB is equal to root 3 VP angle 30 degree, right, and VL is equal to we are writing root 3 VP. So, VL angle 30 degree. VBC is root 3 VP angle minus 90 degree, that also we have done it. So, that will be VL angle minus 90 degree, where root 3 VP is equal to VL, and VC is equal to root 3 VP angle minus 210 degree, that is VL angle minus 210 degree. This all these things in the phasor diagram we have made it, right, all these things are there, that your what you call VAB root this one, VBC is this one, and VCA is this one with respect to your VAN, right. That is your that from this I am not going to the phasor diagram, I mean from this phasor diagram. Again I have to go on top, right, just hold on here from this phasor diagram with respect to that, look, this is angle 30 degree, with respect to Vn it is 90 degree, and with respect to Vn this is your minus 210 degree, right. So, that is your what you call that your VAB, VBC and VCA, right. Now, if you make divide VAB by VBC, if you make VAB by VBC, it is VL angle 30 by VL angle minus 90. Therefore, VBC is equal to, it will go up, it will be 120 degree. So, VBC is equal to VAB minus 120 degree, right. Similarly, VAB upon VCA if you make, you will get VL angle 30 by VL angle minus 210 degree, you will get VCA is equal to VAB angle minus 240 degree, or you add 360 with that, other way VCA is equal to VAB angle 120 degree, right. This is the relationship. Now, balance star delta connection. Next will come source is star, but load is your delta connection. So, this is my source star and this is your my delta connection, right. Now, question is that Just let me reduce this thing little bit first for your explanation. So, if you look into this circuit, that this is my VN, this is my VBN, and this is my VCN, and this is my delta connector load Z delta, Z delta, Z delta. So, this is a line current IA, right, this is line current IB, and this is line current IC, right, and in that load phase current, this is I capital AB, I capital A to B, this is A to B, I capital BC, B to C, and I capital C to A, right. This is my what you call my your phase current, right, and this is my line current, this is my phase current. Now, if you apply, for example, we will come to that, but I am telling you, if you apply KCL here, this current is coming, right, incoming. So, this current is IA, this ICA current also coming here, so plus ICA, and this current is your what you call, it is leaving, so it is minus IAB is equal to 0. That means my IA is equal to IAB minus ICA, right. So, similarly, you have to apply KCL here, you have to apply KCL here. So, in this case, line current is not is equal to phase current, because this is the line current, after that this is the phase current and this is the line current. So, we have to find out some relationship between the line current, this is the line current, phase current, and this is the line current, right. So, this is delta. So, in this case, so let me just increase the zoom. So, this is the circuit I told you, right. Now, for balanced star delta, so VN again star case angle 0 degree, VBN angle minus 20 degree, and VCN VP angle 120 degree, and we also know VAB is equal to VAB root 3 VP 30 degree. If you look into the circuit, right, is your what you call that your VAB is equal to this one. Just let me go up, that here it is VAB small, V small ab is equal to V capital AB. It is very simple, because if this is your B and this is your A, right. So, if this is your VAB, right, this is your VAB, and this point same, because no element, nothing is connected here, and this point is B. So, nothing is connected here. So, VAB is equal to VAB, right. Similarly, for BC, CA, right. So, let me clear it. So, that means my VAB is equal to V capital AB root 3 VB angle 30 degree, same thing. VBC also same thing, root 3 VP angle minus 90 degree. BC also VCA root 3 VP angle minus 210 degree. Now, IAB is equal to VAB upon Z delta, because this is my circuit. That means this voltage, right, that your VAB, that is my VAB, this voltage A to B and is equal to VAB, right, same voltage impress, and this is my Z delta IAB. So, IAB is equal to VAB upon Z delta, right, for this phase, right. So, same thing here we are writing, IAB is equal to VAB upon Z delta, IBC is equal to VBC upon Z delta, IC is equal to VCA upon Z delta, right. So, now another way to get this phase currents is to apply KVL. For example, applying KVL around loop, say A, B, B, A, N, A, right. I mean, if you do so, if you apply your what you call KVL, then what you can do is apply KVL in this loop. You apply KVL in this loop. In this case, what will happen? If I am coming like this term, say Z delta into IAB, then encountering plus terminal first, plus VBN, then minus VN is equal to 0, right. That means my IAB is equal to VAN minus VBN upon Z delta, and we got no VAN minus VBN is equal to root 3 VP angle 30 degree. We got it, no, same we will get it. So, that is why IAB you can write like this. Similarly, for the other mesh also you can do this. This is for one, similarly for other two you can do it, right. So, that means here, that is why we are writing this one, IAB is equal to VAN minus Z delta, and that is actually nothing but VAB, we got it, the phasor diagram, by Z delta, that is V capital AP upon Z delta. Similarly, for BCCA you will get it. So, line currents are obtained from the phase currents by applying KCL at nodes IBC. I showed you at node A, if you apply, IA will be IAB minus ICA, IB will be IBC minus IAB. I showed you one, here all this your here at node A, node B, node C you apply KCL and you will get this equation, right, you will get this equation. Similarly, IC is equal to ICA minus IBC. Now, IAB upon ICA, IAB is equal to VAB upon Z delta and ICA is equal to VCA upon Z delta. If you do so, IAB and IC will be VAB upon into Z delta into Z delta upon VCA. So, Z delta will be cancelled. So, IAB upon IC actually will be VAB upon VCA. It is proportional to their like IAB phase current and ICA, it is just a same thing as the line to line voltage VAB upon VCA, right. So, IAB upon ICA is equal to VAB you write and VCA is equal to VAB angle minus 240 degree you substitute. So, VAB will be cancelled, therefore, ICA will be equal to IAB angle minus 240 degree. That means also IBC similarly you will get IAB angle minus 120 degree. You please do it for you take your what you call IAB upon IBC, you will get your same relationship minus 120 degree. This is very simple, nothing is there, just you put in that and step by step you will do, you will get it, right. Therefore, you will get IBC also IAB minus 120 degree, it is balanced. So, in this case, therefore, we know IA is equal to IAB minus ICA. So, IAB keep, but ICA is equal to IAB angle minus 240 degree. You put here IC is equal to minus IAB angle your minus 240 degree. If you simplify, you will get IA is equal to root 3 IAB angle minus 30 degree. That means line current is equal to root 3 times the phase current and angle is minus 30 degree, right. And magnitude wise, line current is equal to IA, IB, IC, that is line current magnitude, and phase current IP is equal to mod IAB, mod IBC, mod IC is equal to phase current, right. So, in this case, this is my phase current. So, IL actually line current is equal to root 3 times phase current for delta connection, right, load. So, line current earlier we saw star connection, your line your what you call line voltage is equal to root 3 times phase voltage, and for delta connected load line current is equal to your what you call going to that is your root 3 times phase current. So, IL is equal to root 3 times phase current, right. So, this is your just from one relationship you will get it, rest you take that your 120 degree apart, right. So, no need to do it, just is a balance. So, you will see that it will be just 120 degree apart, right. So, if you draw the phasor diagram, this is my IAB, this is my IBC, this is my ICA, this is my phase current, and this is and IA is lagging from this phase current by minus 30 degree. That is why this is IA 30 degree, then IB, then IC. Similarly, you draw just 120 degree apart between among your what you call between your line current as well as when you draw the phase current, that all these phase current are 120 degree apart, right. So, this is figure 15 and this is my phasor diagram, right. Therefore, IA is equal to root 3 IB angle minus 30 degree, IB is equal to IA angle minus 120 degree, and IC is equal to IA angle 120 degree, right. So, this is actually our relationship, that is line to voltage. So, there should not be any confusion, right. So, an alternative way of analyzing star delta circuit is to transform the delta connected load to an equivalent star connected load using the delta wise transformation. This not much done, because it is same as a DC circuit, right. I never wanted to make these things much lengthy. So, Z star is equal to Z delta by 3. If you do so, then after this transformation you have a star star system as in figure 10. So, this is your what you call that you have if you convert delta to star, it will be a star star system, like your figure 10 we have given start source your star load. So, here it will be ZY is equal to Z delta by 3. Now, if you see this equivalent circuit like your single phase, so this is Vn, this is Ia, and ZY is equal to Z delta by 3, right. As simple as if it is a single phase, it is balanced, so represented by only phase A, right. So, this allows to calculate only the line currents, right. So, star delta transformation or delta star transformation both are possible. If you feel, you can convert it to delta to star or star to delta. So, take a small example. A balanced ABC sequence, that is star connected source with Vn is equal to 100 angle 10 degree, voltage connected to a delta connected balanced load, that is 8 plus J4 ohm, right, per phase. Calculate the phase and line current. Look, Z delta is given 8 plus J4, that is 8.944 angle 26.57 degree. Now, if the phase voltage Vn is 100 angle 10 degree volt, right, then the line voltage will be VAB is equal to V capital AB root 3 Vn. Just now we have seen it is root 3 Vn angle your 30 degree, and VAB is equal to root 3, then it is 100 angle, your VAN is equal to 100 angle 10 degree. So, root 3 100 angle 10 plus 30. So, 173.2 angle 40 degree volt, right. Therefore, IAB, that is the phase current, VAB upon Z delta. So, if substitute all these values, you will get 19.36 angle 13.43 degree ampere. The rest are just shifting 120 degree, right. So, IBC will be IAB angle minus 120 degree. So, it will be 19.36. So, 13.43 minus 120. So, it will be magnitude of current remains same, minus 106.57 degree ampere. Similarly, IC is equal to IAB angle minus 240 degree is equal to IAB angle 120 degree, because it is minus 240. So, making it IAB 120 leading. So, that is 19.36, 13.43 plus 120. So, 19.36 angle 133.43 degree ampere. Actually, these things are very simple. Just little bit to go through good book and just listen what had been discussed here, and nothing to be worried about this thing. It seems very simple, 3 phase, right. So, this is ampere. So, line currents, we know IA is equal to, just now we have derived root 3 IAB angle minus 30 degree. So, substitute your all these things, IAB you substitute. So, IAB is 19.36, angle was 13.43 degree minus 30 degree. So, it is IA is equal to this much, right. Similarly, IB is equal to IA angle minus 120 degree, you substitute IA value. So, IB will be this much. Currents are same magnitude, balance 33, and angle is just your what you call, if you take the difference of between these two angles, you will find it is minus 120 degree, right. It is ampere. Similarly, IC is equal to IA angle 120 degree, you will get IC is equal to 33.53 angle 133.43 degree ampere, right. So, this is your what you call this your that example. Now, exercise. So, this is your what you call, this exercise is given to you, you will solve it. That single one line means single line, one line voltage of a balanced star connected source is given this one, right. If the source is connected to a delta connected load of this much of impedance 20 angle 40 degree, you have to find out the phase and line current assuming ABC sequence. This is an exercise for you, but answer is not given, right. So, you will do it. Now, next is balanced delta delta connection, right. So, in the case of balanced delta delta connection, in the case of delta load and your delta source, so in that case your line voltage and phase voltage remain same, right. So, if it is a delta for delta connection, this is whatever your VAB will be impressed across this, right. Similarly, V capital AB same, because here for the delta connection your line voltage and phase voltage remain same, right. So, here it is both delta, right. So, this is your balanced delta, this load is delta and source is also delta, and philosophy remains same, right. So, or Z delta is given, right. So, and this is the line current IA, IB, IC, this is the line current, but both are delta, and these are the phase current IB, IC, IC. For delta your what you call line, your line voltage is equal to phase voltage. We will see that, So, our goal is to obtain the phase and line currents, right. So, for delta connected source or load, line voltage is equal to phase voltage, because both are delta. There is no question of neutral here, no AN, BN, CN, it is all line to line. So, line voltage is equal to phase voltage, right. So, it is line voltage is equal to phase voltage. So, VAB we know VP angle 0, VBC VP angle minus 120 degree, and VCA VP angle 120 degree. That then line voltage and phase voltage both are same. So, VL is equal to, here it is written here, VP is equal to VL, here I have written here VP is equal to VL, right. Therefore, VL angle 0 degree, this one is equal to VL angle minus 120 degree, and this one VL angle 120 degree, because both are same. So, VAB is equal to V capital AB, VBC is equal to V capital BC, VCA is equal to V capital CA. Here it is same thing, here it is capital A capital V, capital A capital B, nothing is there in the line. So, V small a b is equal to V capital AB, similarly for VBC and VCA, right. So, hence the phase currents are simply IAB is equal to VAB upon Z delta. If you come to this circuit, if you come to this circuit, IAB is equal to VAB upon Z delta, right here. So similarly, your IBC and ICA, this is IBC is VBC upon Z delta, IC is equal to VCA upon Z delta, right. Therefore, applying KCL at nodes A, B, C, similar, same as before. If you apply at node A, B, C, KVL, your KCL, you will get IA is equal to IAB minus ICA, IB is equal to IBC. It's just when you will do this, no, just draw the circuit diagram first, then you will listen to this video lecture, right. Then and you do of your own, and IB is equal to IBC minus IAB, and IC is equal to ICA minus IBC, right. So it is already shown earlier, right. Each line current lags the corresponding phase current by 30 degree. This already we have shown it previous case. So the magnitude IL of the line current is √3 times the magnitude of the phase current, because it is line current and then it is delta connected load. So line current is equal to √3 times phase current, that we have done it. IL is equal to √3 into IP, right. So take a small example. A balanced delta connected load having an impedance 20 minus J15 ohm is connected to a delta connected source. The voltage is 330 angle 0 degree, that is VAB is given. Calculate the phase currents of the load and the line currents, right. So in this case, Z delta is equal to 20 minus J15, so 25 angle minus 36.87 degree ohm. Since VAB is equal to VAB, the phase currents are IAB is equal to VAB upon Z delta. So you know VAB, so put Z, you will get this is the current 13.2 36.87 degree ampere, right. Similarly, IBC you know the relationship, IAB angle minus 120 degree. This IAB you substitute here, you will get this one 13.2 angle minus 83.13 degree ampere. Similarly, ICA you will get IAB 120 degree, so you will get 13.2 156.87 degree ampere. And we know I line current is equal to √3 times phase current angle minus, this all we have derived. Little bit you have to keep it in your mind, right, little bit practice is necessary. So if you do so, you will get a value of IA, IB, IC, magnitude same, angles also if you take, angle difference will be again 120 degree, right. Magnitude is all 22.86 degree, 86 ampere, and these are the angle, right. So this is ampere, ampere, ampere. Another one is balanced delta Y connection. In this case, your what you call that source is delta, but load is star. So when load is star, in this case line current is equal to phase current, because same current is your what you call the same current I is going entering here, right. So line current is equal to your phase current, right. So but your what you call, this is voltage source, your what you call, and this is your delta, source is delta. So in here also same philosophy will be there, that your phase voltage, your line voltage will be √3 times phase voltage, and this current IA, IB, IC, right, and this is capital N, and this is ZY, ZY, ZY. Source is delta and load is star, but here line current is equal to phase current, right. So but here your what you call here phase voltage is equal to line voltage by √3, because line voltage is equal to √3 times phase voltage, right. Rest will remain same. So this is the circuit diagram, and all polarity as instantaneous polarity. I told you how to mark it. So that means VAB is equal to same thing we have done, VP angle 0 degree, VBC is equal to VP angle minus 120 degree, and VCA is equal to VP angle 120 degree. So VL angle 0 degree, VL angle minus 120 degree, VL angle 120. Now apply KVL to loop this one, right. So what you will get? So if you apply your I mean this one, if you apply your this here, if you apply KVL here, if you apply KVL here, it will be IA into ZY, right. So and current, this is IA flowing this, but this current is going this way, so it will be minus IB into ZY, and it is encountering minus terminal first, so minus AB is equal to 0, right. This way you can write that equation we have written here, that equation we have written here, IA ZY minus IB ZY minus VAB is equal to 0, that means IA minus IB is equal to VAB upon ZY, that means IA minus IB is equal to VP angle 0, because VAB is VP angle 0, right. ZY is equal to VL angle 0 by your ZY, right. So, here it is given that VAB is equal to VP angle 0 is equal to your line voltage, right, VL angle 0. So, this is upon ZY, IA minus IB, but IB lags IA by 120 degree, we know that IB lags 120 degree. Simply substitute IB is equal to IA minus 120 degree. You put it here and you simplify. If you simplify, you will get IA is equal to VP upon root 3 divided by angle minus 30 degree by ZY. So, line voltage, your VP as your what you call it is that can be written as VL upon root 3 angle minus 30 degree upon ZY. Here we have written, no, here we have written that your VAB is equal to VL angle 0, VL angle minus 120, VL angle minus your plus 120 degree, right. So, similarly, here also you write VL by root 3 angle minus 30 upon ZY, right, Z star or ZY. That means, similarly, your IB is equal to IA angle minus 120, this IA you substitute here, this IA you substitute here, you will get VL by root 3 angle minus 150 by ZY. Similarly, IC is equal to 1 angle IA your 20 degree. So, put IA is equal to here, you will get VP upon root 3 angle divided by ZY and angle 90 degree. So, VL upon root 3 angle 90 degree upon ZY, right. So, this only thing is that you have to remember, nothing to be this thing, very simple it is, right, because its phase difference is just 120 degree lagging or leading, right, and just you have to simplify. And here we have to look at phase voltage, your what you call for delta source, phase voltage and line voltage remain same for delta source. I mean, if it is a delta source, is phase and line same. So, phase voltage is equal to line voltage for the delta source, right. When source is delta, line voltage is equal to phase voltage. That is why here it is taken line voltage is equal to phase voltage. That is why all these things is replaced by phase voltage, because source is delta, right. So, line voltage is equal to phase voltage. These certain things you have to keep it in your mind, right. So, I mean, if you try to represent this by your what you call whatever you have got, say for phase A, right, if you see that IA is equal to VL upon root 3 angle minus 30 upon ZY. So, if you represent it by your VAB upon root 3 angle minus 30, there is nothing but VL upon root 3 minus 30 degree, and this is your ZY, this is the current flowing IA. So, IA will be simply VL upon root 3 ZY angle minus 30, but this is equal to this one, because VAB is nothing but the VL. So, this is represented by only one phase, right. So, this way you also can represent. So, similarly, if you draw the phasor diagram, this is your VAB, this is VBC, this is VCA. So, if you try to find out, this thing, your what you call, if you try to make this delta, so this is my VAB, this all 120 degree, 120, this is my VCA. So, this is my VBC, no. So, just let me clear it. This diagram actually it will be like this. This is my VBC. So, this is my VBC is drawn from here. This is VBC and this is my VCA. So, this is my VCA, this one. So, this is my VCA and this is my VBC and this is V. That is why this is my VBC, whatever is here, that is my VAB and this is my VCA. Just we have made completed this triangle, and if you join all, it will be same actually. This is my, say something is marked this point as N, right. So, this is figure 21, and if you do so, this angle is 30 degree, right, and your VAN, your what you call VAN is nothing but your VP, VBN also VP, these all the your what you call all this your magnitude. So, that means this one, this VAB, right, VAB, this is actually this portion actually VAB by 2, it is half, it is equilateral triangle. So, VAB by 2 is equal to, this is VAN, this is actually VP, right, because this is the magnitude VAN. So, this is VAN is equal to VP, right. So, it is VP then cos 30 degree, right, VAB by 2 is equal to VP cos 30 degree, right. That means this one actually your VAN cos 30 is equal to VAB by 2 magnitude only, right. So, VP by 2 is equal to VL by 2 from this diagram only, right, magnitude we took. So, that means your what you call mod VN is equal to VL upon root 3 cos 30, your what you call root cos 30 is equal to root 3 by 2. So, your what you call that your phase voltage is equal to VL by root 3 is equal to your line voltage by root 3. otherwise line voltage is equal to root 3 times phase voltage. Therefore, we can write Vn is equal to VL upon root 3 angle minus 30 degree, right. So, so that means this is my Vn, right. So, it is in this direction Vn, that means this is my, say, just as a reference I am putting, this is Vn if I make it, right, because this is this direction. So, Vn will lag from Vb by minus 30 degree. So, that is why your Vn is equal to VL upon root 3 angle minus 30. So, Vp upon root 3 angle minus 30 degree. Similarly, for Vbn and similarly for Vcn. That means, if you plot it here, so I mean this is my what you call Vn, Vbn, Vcn. If you plot it here, so in this case it will be what you call Vn, right. So, this is my Vn, same as before, right. Earlier it was shifting 30 degree, but rotated by 30 degrees is Vn, right, same as before. So, this is then Vbn is equal to Vp upon root 3 angle minus 140 50, and Vcn will be again Vp upon root 3 angle 90 degree, right. So, this is your what you call, and Van is equal to your Ia into Zy, that is VL upon root 3 angle minus 30 is equal to Vp upon root 3 angle minus 30 degree, because source delta connection source line voltage is equal to phase voltage. So, we know Vbn is equal to Vn angle, because angle minus 120 degree, because it lags by 120 degree, just those relationship we have to use, and if you put Vn here, and this Vcn is equal to Vn 120 degree. So, this is your what you call, if you substitute Vn is equal to Vp by root 3 here, it will be Vp by root 3 angle minus 150 degree, and if you make it here, your Van is equal to Vp upon root 3 angle minus 30, it will be Vp upon root 3 angle 90 degree, right. So, with this, thank you very much, we will be back again.